Hi, welcome back to Missing Chemistry. This is electron configuration of potassium. Potassium is the 19th element on the periodic table, so we're going to write a 19 right here. Okay, and its atomic mass is 39. That means potassium has 19 protons, and since it's electrically neutral, it would have to have 19 electrons. And what about the AMU? Well, you go AMU minus protons equals the number of neutrons. So we go 39 minus 19 equals 20 neutrons. All right, so we're going to put a 20 there. Pretty darn snarly, eh? So now, but before we do the electron configuration, it's really important to remember that the S subshell holds 2 electrons, the P subshell holds 6 electrons, the D subshell holds 10 electrons, and the F subshell holds 14 electrons. Also, we're going to use the off-ball principle right here, which is called the Dyno rule. We're going to start going down the slide progressively until we run out of electrons, right? So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So let's count our electrons up. And we should have 19 electrons. 2 and 2 and 6 make 10. 2 and 6 make 18, plus 1 makes 19. Snarls. Alright, so let's look at our orbital notation. Now remember that Hund's rule says for every sublevel, you have to put an up arrow first in that sublevel and fill it before you can do the down arrow to fill it. Well, let's look at 1s. 1 subshell, so go up and down, you're done. 2s, 1 subshell, up and down. Now, 2px, 2py, 2pc are 3 subshells, right? So we go 1, 2, 3, 4, 5, and 6. Then 3s, 1 subshell first, up and then down. Then 3px, 3py, 3pz. We have 6 electrons there. 1, 2, 3. There goes all the ups, now the downs. 4, 5, 6, and last but not least, 4s is an up arrow. Now, let's look at the noble gas notation that's closest to potassium. Well, that is going to be argon, Ar. So we're going to put Ar into our noble gas, right? And then we're going to look at our valence shell. Our valence shell is our last shell holding electrons. And there it is, it's 4s1. So we're going to write 4s1. Pretty darn cool and snarly, by the way. Now, let's look at a couple of things. What is the principal quantum number, the N value, for potassium? Well, potassium happens to be in the 4th period. So we're going to put period 4. I'm going to put a 4 right there. Okay, potassium is also in the S block. Since it's in the S block, the angular momentum value is going to be 0. Same thing with the magnetic number. If it's in the P block, which it's not in the D block, it's not in the F block, it's in the S block, right? So the magnetic number would have to be also 0. Okay, great. One last thing. Look at this last arrow. Is it going up or going down? It's going up. So the spin number is going to be 1/2 positive. Well, listen, you guys, you be snarly, and we'll see you back here at Missing Chemistry.